Good afternoon, everyone. Thank you for joining my session. I will be discussing how machine learning can be applied to optimize performance in high volume transaction system. So, modern enterprise platforms, they handle millions of concurrent requests. Maintaining performance, stability, and efficiency at a scale is a major engineering challenge. Machine learning enables system to predict demand, scale intelligently, and optimize performance proactively. This is about myself. My name is Vivek Kumar. I am a staff developer at Whitetech Systems Group, which is now Majesco. I have over 16 years of experience building scalable enterprise platforms across insurance, finance, and cloud native environments. My focus has been on designing microservice architecture capable of handling massive concurrency while maintaining performance and reliability. So, in this session, I'll share how machine learning can leverage system telemetry to predict bottlenecks and infrastructure automatically. When I say about telemetry, is nothing but you have your continuous data log about your CPU utilization, all the requests. Those will be used. We'll take care of those in. I will explain about those in next slides. So when I talk about the static rules versus machine learning, so here is the thing: traditional performance optimization relies on static rules such as scaling when CPU crosses a threshold. For example, it crosses 70%, then some event will be triggered. And after that, we take some actions, but damage is already done. Downtime is already there. Latency is there. System becomes slow. So many problems. However, these approaches are reactive. By the time scaling happens, performance may already be degraded. But modern distributed systems require predictive and intelligent scaling to maintain consistent performance. Next. So, what we are going to learn today? I will cover four key areas. First is modern microservice architecture. Second, how telemetry becomes your training data for machine learning techniques. ML driven, third is ML driven optimization strategies. And finally, some real world implementation examples we'll discuss. So, now this is about the architecture foundation. Modern transaction platforms uses microservices, REST APIs, Kafka event streaming. This architecture enables scalability but also introduces complexity in performance optimization. So nowadays, if you see, almost many projects are using the same design, like you have Spring microservices. So microservices, basically, we use Spring Boot to implement microservices, but microservices is like a type of architecture where you are moving from monolithic to microservices. Monolithic, you had one big application, you are breaking those services in a small pieces, and everyone has their own database, and they are communicating with each other through API gateway. So what happens here is your everything is fast. You can scale easily. One service is down, but it will not impact the others. Opposite to monolithic, if something goes wrong, it all complete application down, and for any deployment there was a downtime which is not there with this Spring Boot. As I said, telemetry is nothing but you have your continuous data, CPA uses and all. So those things are being used to train your machine learning. So we will come to the next slide where you will see it, how machine learning you establish and you give continuous data and work in predicting. So the moment CPU uses will high, will increase, it will predict it like it is going to crash. So you can scale, you can add more CPU, but in the meantime, you have a log to verify the reason, you can identify the reason, and you can fix it without any downtime. So that's what it is. So telemetry, basically every system generates telemetry, right? Including CPU usage, latency, thread utilization, and request rates. So machine learning uses this telemetry to understand your system behavior, and it predicts your future performance based on this. These are nothing but your machine learning features. So important machine learning features include concurrency level, queue path, action volume, and resource utilization. These metrics help ML models predict system load and performance. So forecasting load, machine learning enables system to predict load spikes before they occur. This allows proactive scaling instead of reactive scaling. So earlier, reactive means something happened and then you are scaling, you are adding more CPUs. But now, the moment it spike goes, and as I said about telemetry, right? So every system generates telemetry data like CPU utilization, latency, and everything. So based on that data, ML already predicts and it forecasts. So you can avoid downtime. These are basically ML of optimization strategies. So ML enables intelligent auto scaling, dynamic caching, and real-time configuration optimization. So that way it helps you a lot. Dynamic configuration means in real time you can change the tuning of the connection pools, timeout values, batch size. You can retry policies across services. So machine learning continuously optimizes parameters based on the current workload characteristics and performance goals. So yeah, they see it also there is adaptive auto scaling. This is what you can scale based on the prediction, not after reaction, not like event happened and then you have to scale it. So these are like three pillars of a machine learning model. Next slide is about the performance comparison versus ML based versus rule based systems. So you can see that ML driven systems improve latency, throughput, and infrastructure efficiency significantly. For example, you talk about a 73% fewer performance incidents with proactive optimization. If you think about efficiency, 28% lower infrastructure cost via intelligent resolution allocation. So when we say about you are saving cost, so how? So if high load, you need more CPU, you need more resources. But if there is a low request in the night time or off season time, so you can, it automatically, it will remove those, you can save cost there. So next slide. Okay, next slide is all about ML models. So ML models, different ML models are different purpose. Very common one is LSTM. It predicts load patterns, and anomaly detection identifies unusual behavior. Anomaly itself says, something is there and your behavior is suddenly different. So this will detect like suddenly your CPU utilization is very high. LSTM says LSTM is long short-term memory, and it basically uses your telemetry and it can tell you the number, more specific things about it. And a regression model, regression predicts resource requirement. As I told about you, the telemetry. So telemetry is nothing but the automatic collection and transmission of system performance data, such as your CPU uses, latency, request metrics of monitoring and analysis. But here, if you say about the LSTM, so as I told, LSTM regression is a machine learning technique that uses long short-term memory neural network to continuous numeric values. So based on your past sequential or time series data. So predicting future CPU uses, future latency, request volume based on historical system metrics. So this is what LSTM is. Yes. So building effective loop. So how this loop works is, as I said, you start with a small, then whatever your result, whatever your telemetry data is, you feed that in ML model, and using that data, it works better. So this feedback loop allows continuous optimization. Telemetry feeds ML models, which generate predictions and trigger scaling actions. So based on the prediction, it can predict, okay, CPU uses are going high. So now it already predicted based on the number of requests are coming or something happening. So you can easily make decision about scaling, and you can scale your application. You can add more CPU rather than something already happened, downtime is already there, and then you are trying to scale it because number of users are more. If we talk about deployment considerations for production, so production is like obviously a very critical environment. So in production systems, reliability is critical. ML models must be monitored, validated, and deployed carefully. So here you see deploying ML models in critical transition path requires careful planning and risk mitigation. Models must deliver predictions with consistent latency and high availability. So ready to optimize with intelligence? If you guys are ready, so I can give you the a more real world example. So machine learning is not just for the data scientist, broader uses are there. So instrument your system slowly, select models aligned with your optimization goals, deploy with proper safeguards, and iterate continuously. As I told you, feed telemetry to the model and it does the prediction better, and based on the prediction you can do the scaling. We discuss about, so what do you understand? So if I talk about the four things we understood or we gave the priority here is basically purpose of this presentation is convincing everybody how moving from a reactive to predictive approach is better. So ML, this transforms performance optimization from firefighting to a strategic forecasting and proactive intervention. It means your prediction is better, you can predict it and you can scale based on your prediction, not based on the reaction. Telemetry is your foundation. As I said, telemetry is nothing but your continuous gathering of your all CPU uses, latency, all this data you feed in the ML model and it works after that. It predicts better actually. So measurable business impact, ML enhanced system delivers superior responsiveness, stability, and resource efficiency compared to static rules. So start small. So basically telemetry will feed and better prediction. So begin with focused one cases, establish feedback loops and expand ML capability. So now this is just for better understanding because many people are aware of AWS and Azure. So these cloud platforms, they already use ML driven scaling. AWS predictive auto scaling forecasts demand and scale infrastructure automatically. Azure Kubernetes service dynamically scales containers based on the workload telemetry. These platforms demonstrate real-world ML optimization architecture. So, yeah, a little bit about this. So, this diagram, I will next slide. I have a diagram. So, basically, this diagram is there. So, it will basically shows the complete machine learning optimization pipeline. So telemetry is collected, which is your very first screenshot, see CloudWatch or whatever tool you use. So telemetry is collected and processed. ML models generate predictions. Auto scaling system adjust infrastructure, which is at the last, you see the containers pod, and prior to second last, if you see already Kubernetes and all. Before that, LSTM, that is your machine learning there. So there they will predict the future, and based on that, you can scale your infrastructure. So this is really just whatever I'm saying. This creates a fully autonomous, self-optimizing system capable of maintaining performance at a scale. So thank you everyone. Here is my LinkedIn ID and my Gmail ID as well. Any question, we can again talk about it. So far, I can just conclude. So the takeaway is performance optimization is shifting from reactive to predictive. Machine learning enables intelligent scaling, improving performance, stability, and efficiency. So thank you for your time. I would be happy to answer any question. If you have any question, you can email me and connect